Let us read first what we mean by a complex conjugate, all right? Let's read this one in here. Aiden, can you see it from here? Thank you. What is a complex conjugate?
The complex conjugate of the complex number a plus bi is a minus bi. If it is found by changing the sign of the imaginary part of the complex number, the real part of the number is left unchanged.
Thank you, all right? So there we go. So when you say a complex number, you copy the real part, you sign change the imaginary part. Okay, so that's what we call our complex conjugate. So in here, we said in here, complex conjugate, if you have a plus bi, then its conjugate will be copy the a, sign change the bi. And how do we do that one in here? Let's do that one for, it's going to be used for dividing complex numbers, all right? Let's see one of those complex numbers here and how we can divide such, okay? Let's see this one. Number 36, right? So we have number 36 in here. We get the following, okay? 36. It says in here, 2 plus 3i all over 2 minus 3i, right? So that's the numerator, and that is the denominator as well, right? Well, let's read our step 0 in here. What do we do first, okay? Cecilia, go ahead.
Make the numerator and denominator are in a plus bi form.
All right, are they both in a plus bi form? 36 and 36 in here, the numerator and denominator. What can you say, McKinsey?
Yeah.
Yes, they are, right? 2 plus 3i, 2 minus 3i. So yes, check on step 0, right? Well, what will be the first step? Let's read this one in here. Kaden, can you see it from here? Multiply.
Multiply up 2 down by the complex conjugate of denominator.
Thank you, right? So up and down, meaning the numerator and denominator. Multiply both by the complex conjugate of the denominator, okay? So once again, I'm just gonna put in here, right? So, you see the 2 minus 3i, and the up is 2 plus 3i, right? So you're gonna multiply both up and down by the complex conjugate of the denominator, right? So, what is the complex conjugate of 2 minus 3i? Once again, copy the real, sign change the imaginary I term. Get it? So with that being said, Anne-Marie, what do you think will be the complex conjugate of the denominator?
Only 2 plus 3.
Very good, right? 2, copy the real. The negative 3i, sign change it, plus 3i. Okay. Do the same above. Whatever you did below, you put the same thing above as well. Are we good? Get it? So once again, multiply up and down, meaning the numerator and denominator, by the complex conjugate of the denominator. Are we good? All right. Step number 2. What do we do then for step number 2? All right. Olivia, can you sit from there?
What are the box of numerator box?
Thank you. Right. So on the numerator, you can do foil or box in there. First, outer, inner, last, or your box method. Below on the denominator, you can use dots. All right. Once again, for our dots, that's difference of 2 squares. All right. If you have a plus b and a minus b, you square the a, you square the b, and then subtract them both. Get? So how do we do this one in here? So let's do the denominators first, right? So if we do dots on the denominator, right? What you're gonna do with the 2?
Square.
Square it, right? Very good, Madeline. What's a square of 2? 4. Yeah, you can use your calculator for such. Very good. Minus, what you're gonna do with the 3i? Square it as well, right? So again, in here, 3i, square it as well. Are we good? So again, that's dots below, right? You square the real, you square the I or the imaginary, subtract them, right? That's why it's called what? Difference of 2 squares, right? Get it? Right? So it's the difference of both terms that are both perfect squares. That's why it's called dots. Get it? Right. Anyway, above, we have done box method in the past, right? But let's try to do FOIL method in here. Okay, just to see that one in here, when you see FOIL method, first terms, right? Okay. Oops. What's that gonna be? 2 times 2? Thomas? 4. Very good, right? Next, outer, right? Where are the outer terms? This and that in there, right? So 2 times 3i, right? Those are the outer ends or the outer terms, right? When we multiply them both, what will that be? Okay? Civil I. 2 times 3i. 6i. Very good. Right? So plus 6i. That's the outer. Right? Next, inner terms. Right? This 3i and this 2i. Inner terms. Multiply as well. Right? What would that be? Okay. Reagan, what do you think? 2 times 3i. I. Very good. Right? So another 6i in here. Right? And what do you think will L be? Right? Yeah. L means what? Last terms. Very good. Right? That's correct. So what's 3i times another 3i? Well, 3 times 3? Logan? 9. Okay. Plus. I times I?
I squared.
I squared. Very good, right? Questions regarding that one, guys? Okay. After that, recall that if you have I squared automatic, that's equal to how much? Once again, I squared automatic is equal to how much from our definition of I being square root of -1? -1. Very good, Madeline. Right? So, in short, you see those I squareds? Just change them to -1, right? So by the way, I'm gonna distribute this one in here. So basically, this one can be written as what? 9i squared. Get it? Okay. And with that being said, then that means this I squared here, let me just get a red marker. Okay? So once again, this I squared here will be -1. Not an exponent, right? But times -1. And this I squared here will be another times -1. Get it? Okay. So, let us complete this whole thing in here. Let's read step number 3, right? Let's read our step number 3. Christian.
Simplify the resulting terms.
All right. And when you say simplify the resulting terms, we need to combine similar terms as well, right? Get it? Okay. So for example, on top, what are the similar terms in there? And how do we combine them? Okay. Anyone? You see it from here, Logan? You see it from here? Which one is similar to 6i?
On the denominator?
On the numerator.
On the numerator, another 6i.
Another 6i, right? And if we combine them, what's that gonna be?
12i.
12i. Very good. Right? Thank you. That is correct. Now this one is 4. Now you see that I squared, that's -1 times 9. Basically this is -9 or -9. Get it? Okay. Below, 2 squared once again is 4. This is -9, right? But this is -1, right? So what's -9 times -1?
9.
Positive 9, right? Very good. That's correct. And then we can combine those similar terms as well. So with that being said, what will be the entire numerator by combining similar terms? Any idea? Candy?
It's -5 plus 12i.
Very good, right? Because the 4 and the -9 are similar. That's -5. Very good, right? And just leave the 12i on its own. Correct? All right. And then below, what's that gonna be? The resulting denominator in here. All right? Magnolia. 9 plus 4? 13. Very good, right? So notice in here as well that you will stop if the following, right? Stop if denominator has no I, right? Get it? Okay. Okay, so you only stop as soon as there's no denominator or I on the denominator, you have already simplified it completely. Get it? Okay. Last one. Last step, number 4. Okay, see that one? Last step, number 4. Okay, Mackenzie.
Express answer in A plus BI form.
Thank you, right? So if you want to express your answer in A plus BI form, what's your A then? You combine these two, right? What's that gonna be? Negative 5 over 13. That's your A, the real part. Plus, what's your BI? See this 12, 13, right? Combine them as well with I, right? So that should be your complete answer in there. Express it in the following, right? Separate the real from the I or imaginary, all right? Good. As you may notice in here, there's no verify by graph because honestly, imaginary numbers are not, we cannot plot them and we cannot verify them by graphing calculator, right?